Right, Matrix, I just want to recap what we did in the previous lesson. What we did is we had a timeline. Okay, and I just want to go through this again quickly. And over a period of 2 months, okay, these being a month, a loan which we call P was repaid by means of 1,000 Rand in 1 month's time, and in 2 months' time, or a month after the first payment, another 1,000 Rand was paid. The interest rate was 6% compounded monthly, which was great. Now the question was, what was the loan? Now what we then did, if you just have a look at this, what we did was, to get this, we kind of treated the whole situation as two separate sort of loans. We called this P was made up of two parts. In other words, a payment 1 and a payment 2 that added up to give you P. And this little P1 was a certain amount of money that was borrowed and repaid by means of that money there, and P2 was repaid by that money there. Okay, so essentially what we did is we said, well, let's look at that 1,000, remove the interest off that one, remove the interest off that one, and then what we can do is we've got P1 and P2, add them up and you get the value of P. Now how P worked was, you took that 1,000 and you said, okay, so that's A into 1 plus the interest rate divided by 12, and you removed 1 month's interest off there. Then to that we added 1,000 into 1 plus 0,06 over 12, and we removed 2 months interest, taking us there. By adding that up, your loan was 1,985 Rand and 10 cents. Okay, so you repaid this amount by means of 2 payments over 2 months, which was great, because all you do is you take this one, you say P is equal to this 1,000, 1 plus the interest rate over 12 to the negative 1. We're going back 1 month, and this was going back 2 months. We did all of this was sort of done in grade 10 and 11, but there's a reason for me doing that, because what if I had payments being made of a loan which normally would be, say, 5 years, which would be 60 months? So you'd have 60 of these little calculations, which would be very difficult to do. Now let me introduce you to another formula that works brilliantly for this. You don't have to derive it. In textbooks it's derived, but we're not going to worry about that. It's referred to as the present value, and what it says is that you're going to take your monthly, or whatever if it's half yearly, quarterly, we're working in months here, and you're going to say X into, now it's going to go the other way as compared to the future value. It's going to go 1 minus 1 plus I to the negative n, and all of this will be divided by I. Now they give you this on the formula sheet, and you just have to learn it. I is your interest rate as a decimal, N is your number of payments, X is the 1,000 Rand, the equal payments, and P is the loan. Okay, you borrowed money and you're repaying it. Now if you look at this, if you take a timeline again, now I want to show you, here we go. The loan, P, was repaid by means of 2 payments of 1,000 Rand 1 month after the granting of a loan. The number of payments was 2. Your interest rate is 0,06 over 12, which is great, and we want to find the value of P. So all we do is we say P is equal to the monthly payment, which is 1,000, 1 minus 1 plus 0,06 over 12. How many payments are there? 2, but we've got negative. It sort of ties up with what we did with the negative exponent previously, over 0,06 over 12. So we sub into this formula 1,000, the interest, there's I, 1 plus it to the negative number of payments. It's almost as if you're removing 2 months worth of interest off the thousands. Okay, and then what do you get? Now work this out, check it out in the calculator and see what you get. Guess what? Okay, try it, plug it in, use the fraction button, and let's see what we get. What would we get? Something amazing. That amount, believe it or not, is going to amount to 1985,10. Is that not amazing? That is exactly the same as what you do like here. Isn't that incredible? So instead of just taking each of these back and removing interest, we've got a formula called the present value annuity formula that helps us. Now the advantage of this cannot be overestimated. Right, folks, let's have a look at this example. Suppose that an 8-year loan, 8 years, that's a long time loan, is repaid by means of these equal monthly payments of R1,000 starting 1 month after the granting of the loan. Calculate the amount borrowed, the present value P of the loan, if the interest rate is 6%. Now remember, this is the same as last time, but this time we don't have 2 payments over 2 months. We've got an 8-year period. Okay, so let's have a look at the timeline. Okay, if you look at this, there's T0. Then 1 month later, R1,000 is paid in. A month later, another R1,000 is paid in. This is your loan, your present value. And this goes on for a period of 8 years. Now, how many months are there in 8 years? You guessed, 96 months. Okay, so if you look at this, 8 years is made up of 96 months. So in other words, there are, if you think about it, have a look at this carefully. There are 96 payments over an 8-year period that we span of payments made of R1,000 per month. Okay, but now how on earth are we going to say, well, let's take this one back and then this one back, and we keep doing it? That'll be 96 little calculations. So we need another formula, and you guessed it. When you borrow money and you're repaying it, you borrow money in the now and you're repaying it, you then say this: P is equal to 1,000, that's your equal payment, into 1 minus the interest rate's exactly the same as before. So what's this? 1 minus 1 plus that interest rate to the negative, how many payments are there? 96. All over 0.06 over 12. Now people, that is the number of payments. And you notice there's always a sort of a gap between the loan and the first payment. This is where the formula works. When you borrow money, you always repay it a month later or a half year later. These are always equal, gaps. Okay, so if you work it out, you've got a position to work out what you originally borrowed. So let's see if we use a calculator. Let's do it. So we can see this is 76,095,22. Now this is what you borrowed, but you've actually, if you think about it, paid 96 times 1,000. In other words, you repay 96,000, but you only borrowed 76. Wow. Okay, but you see, the present value formula deals with loans. The future value deals with investments, saving for the future. This is about borrowing money. Okay, stay with us. We're going to do another example. Okay, let's look at this example. David takes out a bank loan to pay for his new car. He repays the loans by means of monthly payments of R4,000 for a period of 5 years. Now what would that be? 12 times 5. 12 months in 5 years is 60 payments. Ouch. Okay, starting 1 month after the granting of the loan. Look at this interest rate, terrible. They're charging him 24% per year compounded monthly. So that would be an interest rate of 0.24 over 12. Okay, now let's see. The problem with this is, what is the purchase price of his new car? So remember, he went and bought a car, so he borrows money from the bank, which means there's a loan, which is really the cost of the car, but he borrows. But he's going to pay to the bank a lot of money, and it's not just R4,000 multiplied by 60. Okay, he's going to pay interest on this. So let's draw a timeline and assess this. Okay, so what has he got? A bank loan. So David's going to buy a new car. So here we go. So let's just draw a timeline. He buys a car, let's call it P for loan, the purchase price. Then he gets a bank loan, and 1 month later he repays the loan by means of 4,000. A month after this, he pays another 4,000, and this thing is going to go on for 60 months, which is a 5-year period. Then he's going to stop. So, and the interest rate is 24% compounded monthly. Okay, the question is, what is the purchase price of the car? In other words, what is the loan, the bank loan, going to be? Well, it's present value. He's borrowing money from the bank, so it's a loan. So P, now remember, you borrow money and you pay back every month with interest logged in, actually latched into this. So it's 4,000 into 1 minus 1 plus 0.24 over 12. There's 60 payments, but we use the negative there. Let's make it look decent. There we go. That's going to look a lot better there. 60 divided by the interest rate. Okay, remember it's 1 minus 1 plus I to the negative n. Okay, so you got it. And all you now have to do, watch how brilliant this is, work this out in a calculator. Okay, now let's see if you get the same as me. Go and check that. This is going to give you, if you think about it, it's going to give you, look at this, 139,043,55. 139,043 rand and 55 cents. Okay, if you think about it, 4,000 rand per month multiplied by 60. Okay, that gives you 240,000 that he pays. And look at this, he borrows that but pays 240,000. What a disaster that is. Okay, so he's repaying, look at this, he's going to repay 200, if you think of it, 60 times 4,000 is 240,000 for the car that he pays originally 139. What a awkward thing. Okay, all right, so people, watch out for this. Let's look at another example. Okay, look at this example, guys. How much can Lerato borrow from a bank? She's borrowing money from a bank. It's present value. A lot of money is borrowed now. If she repays the loan by means of equal, now watch this, quarterly payments of 2,000 in 3 months. Remember, a quarter is every 3 months. It's 4 times in the year. The interest rate is 18%, calculated quarterly. Okay, so we're going to work in quarters, and the duration of the loan is 10 years. Okay, so let's see this. Okay, if we take a timeline, okay, this is going to be a 3-month period, or as we call it, 1 quarter. Okay, now if you look at that, we're going to go, and she's going to start by repaying. Let's just go and check that. It's going to be 2,000 rand every 3 months. Okay, there we go. Every 3 months, and she does this for a period of 10 years. Okay, if it's 10 years, and we've got 4 quarters in a year. Okay, there's 4 quarters in a year. 3, 6, 9, 12. Okay, every 3 months. That gives you a total of 40 quarters. So the number of payments is going to be clearly up to 40. There, okay, 40 payments. All right. Now the question is, what is the present value of the loan? Okay, well, very easy. This is why the formula works brilliantly. P is equal to 2,000 into 1 minus 1 plus, and the interest rate was, if we go and have a look at it quickly, what was the interest rate? 18% quarterly. 18% quarterly, so it's 0.18 over 4. There are 40 payments, all right, divided by the interest. Okay, 40 payments there, and there we go. What a pleasure. There you've got it. So you can work it out, and the answer to that will come to about 36,803,17.